Subtract and add. Let's learn some math. Subtract and add. Let's learn some math. Let's learn some math. Let's learn some math. Let's learn some math. 1 plus 1 equals 2. 1 plus 2.
Okay, so this was the assignment that we had, and we were supposed to work on. Most of you, majority of you did very well. Looking at the number of response I got, I can say about 80% did well. We all did very well. It means that we really understood the concept. Okay, so I have some hands raised. I would like to know whether it is for a question or in relation to what I asked earlier.
Yes, it's for a question.
Okay, go ahead.
Please, what about those who weren't there for the lesson? Would you be going through it?
Yes, I will touch on that, and then I will expect that those of us who went through contribute so that they can learn from us.
Okay.
So let's move to that quickly, whilst others are still joining. So this was the question. Let's take the first one, for example. Okay, so people keep joining, but we'll proceed. The value of a car t years after purchase is given by v of t, which means the function of t, equal to 2,800 minus 4,000 t dollars. And the first part of the question we are going to attempt is to find v4 and state what the value means. So can we have some telling us what they think about the question and how to approach it?
Please, I'm not answering the question, but they said that the value of a car T years after purchase is given by V into bracket T. Why did the question say V into bracket 4?
Okay. So we have a question on board. I expect that some of us would contribute to the question. So can we have someone giving us an explanation? Sorry for that.
Find V into bracket 4 and state what this value means. So V into bracket T is equal to 2,800 minus 4,000 T dollars. So represent T by 4.
Okay, so why are we
Then
representing t by 4?
because we want to find the value of the car in 4 years.
Okay, so I think that is what she was asking about, and I just wanted to push you some more. I don't know if the one who asked, I think Harriet asked. Harriet, did you understand what she said?
Yes, please.
Okay, and then would any other person like to add anything else? Okay, Blessing.
So the V into bracket T in A, they're represented by V into bracket 4. So it means that the T is the time. So the 4 there means 4 years.
Looking at the question, the first part of our solution is supposed to look something like this. Once we have come to understand that the function given is 2,800 minus 4,000 t, and we are supposed to find v4, which is the function of 4. So when t is equal to 4, so we substitute that into our function. Wherever we see t, we are putting 4 there. So we have that for the first part, and then we work out simplifying it. So we have 4,000 times 4. That should give us our 16,000. And then we subtract that from the 2,800, and we obtain the value of negative 13,200. Okay, so this is where some people had it wrong. They got the figure 13,200, but there was no negative attached to it. So the negative there has a meaning mathematically. It means that there is a depreciation or a reduction. We all agree that we are expecting that the cost of a car over the year should increase, should appreciate. I think one of our colleagues actually prompted me of the fact that he or she thought the 4,000 supposed to have been 400. And I understood the person very well because we expect that the value should always be 400. Okay, so I was talking about the negative, that it's not always that in life we get things to be positive, especially those who will be doing businesses. You realize that sometimes you make profit, sometimes you make loss. And we need to describe that in mathematics as well. So in this case, the car's value depreciated. And we are asked to um, give a reason or explain the value we obtain. So one of the reasons we can state is that looking at the value obtained, it means that in 4 years' time, the value of the car reduces to $13,200. Okay, I hope we understand. So moving on to the B part. Um, in the B question, we were told that we need to find T when V of T is 800. So this goes to mean that the price of the car was noted at a point to be $800. And we need to find at what time would the price be that. So once V of T is equal to this, and the same V of T is equal to 800, it means that we can equate these two values because they are all the same. So we can say $800 is equal to 2,800 minus 4,000 T. I hope we agree to this. Okay. So we can do our changing of subjects like we learned in the basic school. And then we get something like this. I think we are all okay with that. Are we all okay with that? Okay. Then from there, we obtain a value of negative 2,000 equal to negative 4,000 T. We can then remove the 4,000, negative 4,000 by dividing both sides with the negative 4,000 so that we can have T standing alone, and then we obtain T is equal to half. So what does this mean? It means that the value of the car would be $800 in half year or 6 months time. So that is the meaning of the value we obtained. Okay, so if your answer is different, look out for the differences and do the necessary corrections. Blessing.
Then please, I would like to add something.
Okay, go ahead.
So for the question two, in a simple form, like your your approach is too confusing. So
Okay,
I would like to add a simple form.
proceed.
So for the 800 equal to 2,800 minus 4,000 t. You can let the 4,000 stand alone. So 4,000 t equals 2,800 minus 800.
Okay, so if I
Then
get your point, you are moving the negative 4000 t to the left hand side,
yes,
whilst you bring the
yes,
800 to the right hand side.
yes.
Okay, good.
So so 2,800 minus 800, it will left with 2,000. So it will
Sure.
be 4,000 t equals 2,000.
Okay,
So to let the t stand alone, you divide both sides by 4,000.
okay. Oh,
So 4,000 t divided by 4,000, the t will stand alone, and 2,000 divided by 4,000, you get half. So
okay,
the
that's
t will
fine.
be equal to half or 0.5.
Okay, that's very perfect. So I like your view of the approach as well. Okay, good. So as we all know it, for especially mathematics, there are several approaches that you can use. And whenever you are using it, just like Blessing just did, make sure that it is logical and then it is producing the right result every time you use it. So, Blessing, thanks very much for sharing your approach as well. Okay, so I think we can move on to the next question. Or do you have any question about this? Anyone having a question? Those who just joined the class today, you have missed a number of lessons. I think about two lessons. We started with relations, understanding what a relation is, and then we came into functions. But you follow. I'll try as much as possible to get you to understand some of the things, even though you are joining us in the middle somewhere. Any questions with regard to what we have here? Okay, if no question, we are moving on. Okay, so for the third part of the question, we are supposed to find the original price of the car. So for this part of the question, it is testing our logical reasoning. So at the time when we have the original price of the car, we expect that at that time there haven't been any years passed. So we take time to be zero. Do we agree with that? Okay, I see Oli Arnold giving me a thumbs up. Okay, Evelyn. Okay, good. Good. Okay, so it means a number of people understands that. So once we get that right, we just substitute into our function. So wherever we see t, we are putting a zero. And at the end, we obtain 2,800. So this means that the original price of the car is 2,800. Okay, so I would like to ask a question if you don't have a question. Or better still, let me give some a few minutes for anyone who has a question before I ask mine. If you have any questions, why do we say a function is a relation? Why is a function a relation? Okay, Olivia.
That's what we say a function is a relation because a function has several inputs and brings out one output. For each input is related to one output. And for like in relation, one to one relation is one output, like one number in the domain to one number in the codomain. And for the any to one to is a lot of numbers in the domain to one number in the domain. So that's why we say function.
Okay, very well, very well. You've done very well. Um, I think you were a bit more mathematical. So let's try and see if we can um, use a basic explanation. Henrietta, am I pronouncing the name right?
Henry, Henrietta.
Henrietta, right?
Yes.
Okay, go ahead.
Okay. I'll try and say a function is a relation because it is one, but it is connected or related to a lot of components. Well, it can also be related to the things around us.
Okay.
For example, when we were learning the one to one and many to one relation,
Mm,
we gave some real world situations as the examples, showing that functions can also be related to our physical world.
okay.
Yeah.
Okay, so why is a function a relation? In simple terms, a function tends to link the domain to the codomain. So it tells us the relationship between two sets. So you have a set of objects, and then the function will describe how one set of objects is becoming the other. So a typical example was the corn mill in real world. For example, we can look at the corn mill. We put in maize or corn, and then the mill will then do grinding. So the function of the mill is to grind and then to give us something out, which is the powdery substance. The same way, when we look at functions, functions would relate one set of objects that we are calling the domain to another set of objects that we are calling the codomain. So function is becoming that relationship or describing how the whole thing is happening. I hope we understand. Okay, very well. So let's try our hands on these other questions. Okay, quickly. Let's try our hands on this one quickly as we proceed. Looking at the examples, the assignments that we went through. So for the function f of x equal to 4 minus 3x minus x squared, we have to find f of minus x. So whilst we work it out, someone should help us understand this part of the question. In a simple term, what are we supposed to do? So far, the females have been speaking. I'm expecting some male voice as we move along. Okay, Blessing's hand is up. Blessing.
My understanding is for the A. It means wherever you see X, you put it will be negative X.
Very good. As simple as that. Very good. Very good. Very good. As simple as that. So we are expecting to substitute negative x into the function, and then we see the output. So that makes negative x as a domain, and then when we substitute, it should produce a function that will give us the codomain or the range. So do we have any value for it? Some can tell us using the mic. Others can also put it in the message section or comment section. If only you can type the mathematical symbols as well. Okay, Jade Davis, hand is up.
Please replace all the functions with x. You replace it with negative x.
Okay.
So f into bracket negative x.
Yes.
4 minus 3 into bracket negative x minus minus into bracket negative x squared.
Okay, so when we simplify that, what do we get then? So what do we get when we simplify?
4 plus 3x minus x squared.
That's 4 plus 3x minus x squared. Okay, very good. Do we all agree? I see only Olivia agreeing. Okay, Gabriel agrees. Emma agrees. Evelyn agrees. Okay. So someone asked why the 3 is positive in the submission. Any other person, not necessarily the one who gave us the solution. Any other person can explain to us why the 3 becomes positive. Venice.
The three becomes positive because we have negative to multiply negative two, which is different. Also, we want to add to it. So when negative two multiplies negative two, we know that negative times negative is positive. So therefore, we get positive two.
Okay, that's fine. I hope we understand. Okay. So, do we have anyone who tried? Okay, I have some hands raised. Jade. Jade, do you have something to say? Okay, what about Empress?
Since why is the x squared negative?
Okay, so let's have an explanation on that as well. Why is the x squared negative and that one did not change to positive? Okay, Jade.
So please, squares can't have a like you can't get negative because it was in a bracket. So it cancelled out. But outside the bracket there was another negative sign. So it affected it after the
Do we understand that? Okay, blessing.
Okay, so I can say that it became positive x squared because when the negative into bracket s squared is, we can assume there's one. So negative one times negative x squared. When you're multiplying two negative, they become positive. So it will be negative x squared.
Okay, do we agree to that as well?
Please, can you repeat it again?
Okay, blessing, can you repeat?
Okay, so I said when the negative into bracket one x squared is, um the negative, we can put one there. We assume there is one. So negative one into bracket negative x squared. So when you're multiplying two negatives, they become positive. So that's why the x squared is positive.
Are we okay with that?
Yeah.
Okay. So On your screen, I have tried to put down all what you have all said. So we are substituting negative x in place of x, and we obtain the first expression. So you notice that the x being negative, multiplying negative, right? Negative, negative should give us positive, and in this case, negative x squared. So the square, you remember indices, it means you are multiplying negative x by itself. So you have negative, negative. That's the nege po, right? You remember that? So negative, negative should give us what? Positive. So meaning that for this bracket, we have positive x. But already we are subtracting, you see that we are subtracting. So we maintain that, and then the result from this bracket is positive. So we end up getting this as our solution. Okay, for the sake of time, I would like you to keep the B part of the question, and then you go and try your hands on it. I'll add another set of questions, so I'll need you guys to write it down quickly so that we can move on. So let's write down the questions quickly. Okay, so I would like us to do this as an assignment so that all those who are now joining can also at least have a feel of how to use functions in solving problems. Today we have about 33 plus students in the class as of now. So I'll encourage that all of us would practice it. Try your hands on it. Okay, try your hands on it. Even if it is wrong, you try your hands on it. It is very important. Okay, so we'll move on. So next, we want to look at types of functions very, very briefly. So looking at the definition of functions that we learned the other time, I hope you remember the definition of functions that we took the other time. Okay, so kindly share with us what a function is quickly. You can make it as brief as possible. I'm taking the definition or the meaning because it will help us to understand the types very well. Okay, yeah, Nina,
A function is a relationship explaining how variables are related to each other.
very good, very good. Serena,
A function is a relation between a set of inputs and a set of outputs with the property that each input is related to exactly one output.
we will all agree that a function is a relation between a set of inputs and a set of outputs with the property that each input is related to exactly one output. This was the definition we discussed the other time. And on my slide, you can see that exactly one is bolded. And I hope we understand that statement. Okay. So having understood that, I would like us to guess the types of functions that we have or we can speak of. Looking at the type of relations, we did type of relations and we went through the explanations. Relations. Bernice.
If you have one-to-one function,
Okay. Why do you say there should be a one-to-one function?
because we see that um, the function, they said the relationship between each element of the domain and then one element of the codomain. So, like you take for example, as maybe um, 4 in the domain, we relate to only 20 the in the codomain.
Okay. Very good.
Yes.
Very good. Very good. Any other person? So do we think there will be only one type of function that's one-to-one, as Blessing shared with us. Okay, I see. Is it Elisha, many to many relations, and Amankwa, many? Okay, so I would like you to throw more light on that if you can unmute your mic and share something with us. Yeah, Amankwa. Dansua Upuku, I'll call on you next, okay?
I was thinking that if you have a set, two sets, 1 to 4, and then the output you also have 4, each of them mark onto a specific one, so it will be minutes.
Okay. Please, when you raise your hand, try to keep it raised so that after the first person speaks, I can call on you. When you lower it down within a minute, I will not be able to call you again because it will not be recorded at my end. Or better still, that would mean that you have decided to not to answer the question any longer. But the one who rose the hand, I think I mentioned the name. That's Efia. Is it Efia or Efua? Then this is Efua. You can speak.
Yes.
Efua, okay.
So I think there are two functions, which are the 1 to 1 and then the many to 1. Because in both of these ones, each element in the domain is matched to exactly one element in the codomain.
Okay.
So it means that every member in the domain has only one, is matched to only one element in the codomain.
Okay. Okay. That's great. That's great. So looking at your answers, I would like that we all defend our answers. Those who said many to many, I would have loved you to give us some more explanations. But then, for the sake of time, let's move on. So the key word here is that the function is relating the input to the output, but it's making sure that the inputs are matched to exactly one output. So at the output end, or let's say the codomain, we are expecting to see um, only one for value for each of the domain. I hope we understand. So the first type of function we'll talk about is one-to-one function. And the one-to-one function is a function where each element in the domain has only one image in the codomain. So from the example we see, we have the domain X with the values 1, 2, 3, and 4. In the codomain, we have the values 3, 6, 11, and 18. So you could see by the arrow that each member of the domain is mapping to exactly one member in the codomain. Do you all agree to that?
Yes, sir.
Okay. So let's compare these two functions and examine them critically. The first set of function is said not to be one-to-one. And why is it not one-to-one? When we look at the ordered pair arrangement, we have 2 mapping to 9, which is written this way, and we have 4 mapping to 5. And also we have 11 mapping to 5. Now, from here we can see that the members here are mapping to one element in the codomain, which means that it is a function, but it is not one-to-one. just because you have two elements of this particular domain mapping to only one element in the codomain. So although this example is a function, but it will not be a one-to-one function. As opposed to the second example where we have all the members of the function, that is the domain, mapping to exactly one element in the codomain. So making it a one-to-one function. I hope we understand. So we are saying that for function in general, the members in the domain should be mapped to only one member in the codomain. In simple terms, if we look at this particular function, though it is one-to-one, which is a type of function, what we are saying is that every member here must have a corresponding value in the codomain. So 1 is mapping to 1 is mapping to 3, 2 is mapping to 6, and 3 is mapping to 11. 4 is mapping to 18. Okay, so in that case, this example can be said to be a function because every member in the domain is mapping to a member in the codomain. So in that case, this is a function. But then what makes it a one-to-one function? A one-to-one function is a case where every member in the domain maps to one and only one member in the codomain. So it's having one image. I hope we understand.
Yes, sir.
Do I have a yes or a no?
Yes.
Yes.
Okay. Okay.
Yes.
We see from this example that these two are all functions. These examples are all functions written in this form, the diagram, and then in the ordered form. So though both of them are functions, just because every member in the domain is being matched or mapped to a corresponding member in the codomain. But the problem with the first one is that it is not one-to-one. Because if you look at the members in the range or the codomain, you have both 4 and 11 mapping to one member, which is 5. So in this case, this is not one-to-one, as opposed to the second example, where 4 is mapping to 6 and 11 is mapping to 5. So you can see here that only 11 is mapping to 5 and only 4 is mapping to 6. So this one becomes a typical example of a one-to-one function. I hope we understand. Okay, and can I move on, especially for those who are writing?
Yes, please.
The next type of function we can talk about is the many-to-one function. So we have a first example. In this case, just like the previous examples, all the members in the domain are mapping to a particular member in the codomain. Yet again, you also notice that -2 and 2 are both mapping to one member in the codomain, which means that we have many, at least if you have 2, it's many, it's not just one. So many on the side of the domain mapping to 1 on the side of the codomain. So we describe this particular function as a many-to-one function. And you notice that from the two types of function, in the codomain end, we always have 1. And in the domain part, we can have one or many. So that it goes to confirm the definition of a function that says that a function will link or will create a relationship between the domain, that is the input, to only one member, or will produce only one image. So the image of -2 is 6, and the image of 2 is 6, image of 3 is 11, and the image of 4 is 18. I hope we understand.
Yes, sir.
Okay. So this is also another example of the many-to-one function. And then we also have another example. So you agree with me that this is to give a real life illustration of what a function is doing. Okay, I see hand up. Nina,
Yeah, please, can you explain to me? I didn't get it.
which part?
Limited to one function. This one.
The many-to-one.
Yeah.
Okay, so what I'm saying is that for the many-to-one function, it is a function where the members of the domain, okay, you will see more than one of them being mapped to only one member in the codomain or the range. So if you see in this particular example, -2 and 2 are both mapped to 6. If you look here, you have -1 and 1. Both of them are mapped to 2. It means both of them will produce the same result. If you look at the third example, 3 and 4 are both mapped to C. So you will see that you have at least many of the members in the domain, okay, being mapped to one member of the codomain. So let's look at it this way. If I stand at the domain point, maybe let's say the set X, I can say that I see many arrows moving, especially for these two examples, towards one value. Do you agree with that?
Yeah.
Okay. So in this case, I would describe this as many-to-one. I hope you agree with that as well.
Subtract and add. Let's learn some math.
Okay.
Subtract and add. Let's learn some math. Let's learn some math. Let's learn some math. Let's learn some math.